Hello and welcome to the AI Research Roundup. I am Alex, and today is May 10th, 2025. Okay, today we are looking at a paper from Hugging Face's trending list, published 4 days ago, titled InfoVids, Reimagining the Viewer Experience with Alternative Visualization Presenter Relationships. This research paper introduces InfoVids. These are infographics-inspired videos where the presenter and visuals share a 3D space for a more human-centric experience. They built these using augmented reality, which overlays digital info on the real world, and a custom tool, the Body Object Model, or BOM. This body object model helps tie 3D visuals to the presenter's body and actions. Alright, so this first figure really helps visualize what these InfoVids are all about. We see someone watching one on a phone, and then there is this film strip showing the presenter interacting with a 3D airplane model right there in the same scene. It is not like a separate slide. They are together. This shared 3D space is exactly what the researchers mean when they talk about a new visualization presenter paradigm, aiming for a more connected, human-centric feel, unlike traditional setups where the person and the graphics are in totally different worlds. So, to make this happen, the researchers developed that body object model we mentioned, and this figure shows its system architecture. It has 3 key parts. First, body anchors. These are specific points on the presenter's body, like joints or hands, detected using ARKit, which is Apple's augmented reality toolkit. Second, Viz nodes. These are the 3D visualizations themselves. And third, the Viz handler. This component scripts how the Viz nodes interact with the body anchors, responding to the presenter's gestures and actions. It is how the visuals become tied to the person. Okay, so this table then lays out the different InfoVid designs they tested, like Airplane Vs and Napoleon Vs, alongside a baseline, which is the traditional setup with none of these special interactions. For each InfoVid, the table shows which of 3 key conditions were applied. C1, using 3D physical space. C2, body visualization attachments allowing for two-way or bidirectional interactions, where presenter and visuals influence each other. And C3, one-way or unilateral body visualization interactions, where the presenter mainly controls the visuals. This structured comparison helps them pinpoint what makes InfoVids engaging. Building on those design conditions, this next figure gives us a fantastic side-by-side comparison using Napoleon Viz. At the top, there is the baseline version, the presenter beside a standard 2D slide. But the bottom row shows the InfoVid. The presenter is fully immersed in an outdoor 3D scene, interacting directly with animated 3D figures representing an army. She gestures, and the visualization responds, clearly demonstrating that shared 3D physical space, and the body visualization interactions we discussed earlier, all powered by the body object model. This visual contrast really drives home the difference. Moving to the results, these bar charts vividly illustrate viewer preferences. For each InfoVid type, like Airplane Vs and Napoleon Vs, they compare the InfoVid version against the traditional baseline on several measures, such as perceived presenter immersion, engagement, and whether the presenter felt like they were in the same room as the visuals. In most cases, especially for those first 3 measures, the purple bars for InfoVids are overwhelmingly taller. The little asterisks show these preferences are statistically significant, meaning the positive results for InfoVids are very unlikely to be just random chance. Following those preferences, this figure specifically zeroes in on where viewers focus their attention, on the presenter or the visualization. For each type, like Airplane Viz, the baseline bars show most eyes on the visuals, but with InfoVids, the bars reveal a dramatic shift. Attention swings towards the presenter. The smaller tables underneath, known as contingency tables, which help show the relationship between 2 categories, in this case, focus and presentation type. Quantify this switch. The asterisks confirm these are statistically significant findings, based on tests like binomial and Fisher's exact tests, which essentially tell us these results are very unlikely to be flukes. Alright, so to bring our discussion to a close, it is really striking how these InfoVids can reshape the viewing experience. Through careful study, including statistical checks like Friedman's test, which helps compare different presentation setups, and thematic analysis of viewer interviews, where researchers look for common patterns and feedback, the findings are quite clear. By merging the presenter and their visualizations into a single, interactive 3D environment, InfoVids foster a much more engaging and human-centric performance, notably shifting audience attention towards the presenter. That's it for this AI Research Roundup. Thanks for joining me.